Yeah. And let's share this one. Okay, here is the assignment. Yep. Here is the assignment you have to turn in today, but if you turn this tomorrow, Saturday, you just update the grades. Okay. So what we have to do in this assignment is simplify these expressions, remember? We have to simplify. We have just 2 pages, 4 pages, right? Yeah, it's a long assignment. And there is a graph right here, correct? In this graph, well, if you see the graph, you have to use a calculator and plot this and this. And then you're going to tell me if both are the same. So you see these two look different, but possibly at the moment you plot this one, you get the same thing. Okay, so let's see. I'm page 1. Let's just go to page 1, right? In page 1, you see any problem that bugs you? Pretty much it's okay. No, I didn't. I was not able to solve this one. 1, 2, 3, or 4, or 5, or 6. All of them are equally simple, right? A ver, Rubén, problem 3.
Creo que, no me acuerdo si era la 3 o la 5.
Okay, let me see. Problem number 5. Okay, let's do problem number 5. So you have cosine of pi over 2 minus x minus 1 over 1 plus sine negative x. Okay. Okay, here is the point. What do you need to get this done? Okay, right here. Yeah, this is the expression we have to simplify. So what you need is this one. Well, this is for the AP calculus, but you remember you have this formula booklet. So the identities you need to solve this are right here on this page. Where you see the unit circle, you see the graphs. So you see here the identities with the negative exponent, the identities with the pi over 2, correct? And also, you're going to need some of the next page. These ones right here. These first 3. So these Pythagorean identities that are right here in this first column. Not these ones next, just these ones right here. Yeah, are in page 11 after the unit circle. So you need this with you. With this, you can solve anything, everything. So, vamos a ver. The first thing is I have cosine of pi over 2 minus x, and then I have sine of negative x. Okay, so I'm going to check my identities, right? And then I'm going to have here, okay, let's see the pi over 2. Cosine of pi over 2 is sine of theta. So I can change this by sine of theta, correct? So I'm going to do that. Sine of x minus 1 over, and then this one, right? 1 minus sine of negative theta. Well, I have to go and check the other identities right here. Sine of negative is negative sine of theta, you see? Negative sine of theta. So this is 1 plus or minus sine of x. So I change this by this. Now, possibly I made a mistake because I forgot to put here a minus or a plus. Okay. So this one. This is sine minus 1, and this is 1 minus sine. Are these the same?
Yes.
This is negative 1 times 1 minus sine x. Minus sine x. Over 1 minus sine x. You see? So what I did here, I factor a negative 1. Negative 1 times 1, negative 1. This one, negative times a negative positive sign. There is. So what I did this one to have the same as here in the numerator and here in the denominator. So I can cross this one, and my answer is negative 1. Okay? So this little thing is negative 1. So remember, what we're going to use is these identities, so you have to keep the formula booklet with you all the time to solve this. Okay. A ver, from page 2. No, Sammy, Wami, okay. Okay. From page 2, let me just share the screen. So you have, in page 1, you have this. These ones pretty much are the same. You see, it's pretty much the same thing. Cosine square, tangent square, cosine square. Well, you want to solve 6, or we move on to the next page? 7, 8, or 9? Which one? 7, 8, or 9?
8.
8? Okay.
Yeah.
So, okay. So this is the identity I have to solve, correct? Trujillo. Let me just let me just see this one. No. Kevin Castillo. Okay, here is Kevin Castillo. Oh. I'm on session now. Okay, so let's see this one. So I have secant of this. Now let's see, okay, I have a negative here and I have a pi over 2 minus x. So I'm going to change these two. So I have to go, okay, again. Sine of the negative angle is the negative of the sine of the positive angle. So I'm going to put here equals secant x, tangent x, and here sine x, negative, times cotangent of pi over 2 minus x. So cotangent here is cotangent pi over 2 minus theta is tangent of theta. So I can put here the tangent of theta, correct? In this case, tangent x, because I'm using x, is correct? Okay, what I can simplify here? Oh, tangent with tangent. I cancel the tangents. So I have secant x over negative sine x, correct? Okay. Well, I have this fraction, so I would like to know if I can change this sign in the denominator by something that is not a fraction. So let me just remember my identities. I have here my identity. So I have 1 over sine, you see? So what is 1 over sine? 1 over sine is cosecant, you see? So I can change this 1 over sine by cosecant. So this is secant, right? So this is going to be secant x times negative cosecant x. Again, why? Because 1 over sine is cosecant. So 1 over sine is right here. Remember, this is secant times 1 over negative sine x, correct? That's what I'm doing. I separate it, and then this is cosecant. So this is negative secant x times cosecant x. That's my answer. Okay.
How do you change the negative cosecant to the other side?
This one?
Yeah.
It's very simple because this is a C, right?
Okay.
This is like negative 1. This is like secant x times negative 1 cosecant x. Then I put this negative 1 at the front. That's it.
That's it. Okay.
That's it. Very simple. Okay. Okay, no more questions? Okay. Let's move now to the Next problem, let's see, screen right here. So I solve this one. There is problem 9, there is problem 7. Okay, let's see the next page. Okay, in the next page, we have 3 that look scary. So cosine, cotangent plus tangent pi over 2, 1 plus cosine. This one, 10, 11, or 12. Which one? 10, 11, or 12? 10? Okay, 10. Okay, I have cosine x, cotangent x, plus tangent of pi over 2 minus x over 1 plus cosine x. We're going to see that all these are pretty simple, okay? Okay, here is my expression. I have to simplify. Yes, looks terrible, scary, but it's not such that. Okay, let's see. dx, 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 this is normal. These are normal functions, so I'm not going to touch them now. This is the abnormal. This is something that, okay, this is long. Let me see if I can simplify the thing. So here are my identities. So tangent of pi over 2 minus the angle is cotangent, you see? So I can change this by a cotangent. So I'm going to do that. I say cosine x times cotangent x plus cotangent x over 1 plus cosine x. Correct? Okay. Now, simplify the top. Okay, can you add these two? Well, not really. I cannot add these two because they are not like terms, but I have this common factor. And I have to remember my algebra 1. If I have this common factor, I can factor this. So I'm going to open a parenthesis, it's cosine x, plus, remember here is a 1 times cotangent, plus 1 cotangent x over 1 plus cosine x. Okay, now, do you have something common at the top and at the bottom here? You have something?
Yeah.
Yeah,
Cosine plus 1 is 1 plus cosine. So they are the same, so I can cross them. So my answer is cotangent. So believe me, these are not difficult. It's just replace something by the identities right here. So you have to use this one and you have to look the one that is going to help you, correct? And these are in the formula booklet. You don't have really to memorize them, okay?
Very easy, right, mister? Very easy.
Okay. What else? Okay, let me just go here. So we solved 10. You think you can do 11 and 12? Or you want to try 11 or 12?
Well, how do you do the last one?
Oh, yeah. Last one.
Number
El
12?
último, el último.
The last one from the...
Yeah.
Usen Desmos.
But we just gotta put a graph of one.
This one?
Yeah.
Very simple. Vamos a ver. Let me just take this one.
Super easy. Super easy. Yes.
Of course, it's with Desmos. Let me see. Oh, right here. The last one, the very last one. Right here. So let me just put it right here. Write this one and put this one right here. So let me just stop here. So this is the one. So what they are asking you is to get a table, correct? Yeah, not a big deal. Let's see. If we don't have the calculator, that's the problem, correct? But you have access to Desmos. Okay, escape. So let me just share screen. Right here, let me just take right here. Right here, www.desmos.com, correct? And let's start graphing. Then in Desmos, you have now create an account. Let me just, well, let's just give it like that. So I have here, let me just reduce this one a little bit. Yeah, and well, I'm going to add this one. So expression. So I put just cosine x, right? Divided parentheses 1 minus sine of x. And then you press parentheses, enter, and then you're going to see the shape of this thing. It's like a curvy. Obviously, when this denominator is 0, you have this asymptote, okay? Okay, now let's put the next expression, 1 plus sine over cosine. It's okay, parentheses, 1 plus sine of x, parentheses, divided by cosine x, correct? And then we press enter, and you don't see any new line. So the green line, you can see over there, overlaps the blue line. So the first thing you determine is this one. Cosine x over 1 minus sine x is 1 plus sine x over cosine x. So it's the first conclusion. Let me just show you the board. This is the first conclusion because you see the same graph. You see these two. Okay? Now, how did you get values of this thing? Okay, let's see. How can you get values? Let me see right here. Again, share screen. It's simpler with the calculator, but let me just put a table right here. Table. Okay? And then you put 0.2. And here the y is going to be cosine. Let me see if you take it. Cosine of 0.2 divided by parentheses 1 minus sine 0.2. Enter. And you see right here the point. Yeah? 0.2, 1.223. Everybody see that? So once you put this point right here in Desmos, you click on the point and then you see the value. 0.2, 1.223. This is what you have to write. Well, not here. Let me just find again. Right here. On this table, you have here the 1. And because these are the same, well, you can put the same number, 1.223. Correct? Right here, 1.223. This value is, let me see, right here. 1.223, 1.22. Do you want the next value? Okay, let's go back to Desmos. So I put here in the next value, so I enter. So here, this one, then press enter. No, right here. So here, press enter right here. Then I put 0.4. And then in the next one, the same expression, cosine of 0.4, parentheses, this one, 1 minus sine of 0.4, parentheses. Then, you cannot see? You cannot see the Desmos?
No.
A ver, let me see otra vez. Share screen, Desmos. Now, is there? Okay. Now, you continue using the table. Let me just open here. You see 0.2, 0.4, and then you write here this one. You already saw that both are the same. You see, I erase the blue, is the green. I put the blue, they overlap. So whatever you do with one is the same value for the other one. Then you put here the 0.2, and then you put the expression for 0.2, 0.4, the expression for 0.4, and then you here click only, and you see that 0.4 is 1.508. So it's not that difficult, right? You prove this graphically, right? And then you have to complete the table right here. And then you have here to pretty much sketch the graph. What you see here in Desmos. Right here, you see? Pretty much. Okay. More questions about these problems right here. Let me just go back to the problems. So from this page, all of them are fine. You think you can do this by your own?
Yes, sir.
Okay, well, I let you work.
All right.
Then, so I'm going to upload this. Let's just stop.